I'm going to talk about how in MemSQL we use multi-version concurrency commits to allow reads to run concurrently with writes without having to acquire any locks on the reads. In MemSQL, we use multi-version concurrency control, and the way we implement it is on every key in our indexes, there's a lock-free linked list, and it looks something like this. And in this case, there's no transaction modifying it. So if a scan were to read it, it would see the first version on the list, which is the most recently added version. And in this case, its state is committed. And the scan says, okay, this is committed, it's visible. I'm going to return B for the row that is at this position in the index. The way in which we modify these versions is with transactions adding elements to the list. A transaction first creates a version, and its state for that version points to the transaction state. This is how we commit things atomically. So we add the version at the beginning of the list, it's the most recently added version, and then the transaction, when it's ready to commit, changes its state in memory. The version state still points to transaction, and then the transaction fixes the state in all the versions so that we can reuse the transaction's memory. And now the newest version, C, is at the beginning of the list with state committed. If we have a scan running at the same time as this transaction, it depends on when the scan hits the list. If it hits before the transaction commits, it reads the version state, sees that it's a pointer to the transaction, and reads the transaction state, which is uncommitted. And because it's uncommitted, that row is invisible to the scan. So it reads the previous version of the row. And in this case, it's visible, and the scan can see it and returns that version of the row. And at this point, it doesn't matter what the transaction's state is or what version C's state is, because the scan has already skipped it. On the other hand, if the scan reaches and reads version C's state after the transaction has committed, then version C is visible and we return C. And this is how we can have a scan running concurrently with the write, because the write puts its version on this list and the scan knows to ignore it until that version is committed.